Hello and welcome to the recording of how to deploy microservices on Red Hat OpenShift with UK Cloud. What I want to show you first is how to get set up with OpenShift. As you can see, if I type JOC, I've got the OpenShift container platform command. That's actually installed just by heading over to GitHub, and if you just search actually for OpenShift origin, you can grab your own version of OpenShift from GitHub. Just head to releases, you can download the source there and just put the binary in your path, and then I can just type OC version and I can see what I'm running. Assuming it doesn't crash, you can see it's running Kubernetes 1.6.1 and it says which OpenShift version is actually being used. So the best way to get started is just type OC cluster up and it'll give us an OpenShift cluster to use. And this actually, by default, if you've got Docker running, that's actually a prerequisite I should have mentioned. I've got Docker running here. I'm actually using Docker 17.06. I believe that's the latest version from yesterday. I can check for updates just to be sure. Up to date, yeah. So I'm using the latest version of the beta channel. I actually subscribe, so I'm always getting the latest version running. So let's let the OpenShift cluster come up. Obviously, it can take a while, but not usually this long. Let's see. Dum 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 dum. There we go. Right. And what that does is give you a URL that you can access here. Continue. Ignore the certificate stuff. Check server connection. It doesn't like that. We have to use Chrome. Of course we do. Of course we have to use Chrome. Of course. Because I set it all up to Safari, and of course it's not going to work in Safari. Needs Chrome. So let's open Chrome and ignore the certificate. Proceed. Typical of any live demo. Developer login as per voila. And it gives you a project that you can use off the bat. And this is OpenShift basically. If you've not seen it before, you can see all sorts of things. You've got builds, you've got pipelines, you've got images. Images is where you would typically see Docker Hub and things like that. This is like to store your artifacts such as key.io. Applications, you can see your deployments, you can see what pods and what services you've got running and what routes are going where. Obviously, we've got nothing. So what we want to do is add something into that. Now, we've got here an example project, and I'm going to show you just over in Sublime what's actually in here. We've got two microservices. We've got an API and we've got a front end. Both have a Docker file, which actually just using it's a true service. It's just a Golang app. And all the Docker file does is basically copy the built artifact of the Go binary. The Go binary has been compiled and it's been built and it works. So all we're doing is copying the binary file into our Docker container as a service, and we're specifying the entry point and exposing that front end on port 8080. So the actual Docker container itself is very simple and very similar for the API. We're copying the API binary, putting it in bin API. I've got a time bomb here, which I will explain later. But again, the API being exposed on port 8080. So what I will do now is have a look at how these are being built. So we've got first things first, we need to actually build these Go binaries. And what are these services? What is it that we're actually building? What we've got a front end written in Go, the main Go file. This is actually written by this example is actually from a guy, MJ at Red Hat. He's been very kind to lend me the example for. But essentially, what it is, it's a simple website that will show some images, just some static images. And this is just the list of pages. If I go to the Go page, it'll display the Go logo. If I go to the Red Hat page, it'll display the Red Hat image. If I go to OpenShift, it'll display the Red Hat image. If I go to Kubernetes, it'll display static Kubernetes image. So obviously that is very, very simple in terms of what it's going to do. It's just a front end which displays an image, and these are actually hard-coded images. Now, where we get a bit more complicated and what we're trying to show here is that if we go to the random page, it's going to use some environment variables to pull the API URL, and it's going to fetch an image to display on our front end. So it's a very, very simple example of how a microservice would work. Obviously, most people's microservices are much more complicated, but this is literally just to get an image from the API and display it. It's only getting the URL as well, so it's literally just getting the URL for the image. So if I just have a look at that, the actual Go code itself is nothing too exciting. It's just setting the template variables. I'm not here to teach Go, so you just have to trust that it's just a simple Go app which pulls in some templates, just as you would expect a master page with a title and some content, basically. I'm also putting in here the API password because later I want to cover secrets. I want to show that how to encrypt a secret password and then reveal it on the front end. Obviously, you wouldn't ever reveal secret data. It's just to show that I can manage a secret and update the secret, and it'll filter through in the deployments. So there we have a simple app, and the API is very similar in the sense that it's just got some login information. I mentioned the time bomb earlier. If the time bomb set, it'll bomb out and the API will fail. So what does this actually even do? If you look at the handlers, it will just take the index page actually just talks to XKCD, and it'll pull back a random image URL from XKCD, so that we just get a nice random image each time we call the API. And obviously this URL is going to be used on the front end. Nothing exciting here. Again, I'm not here to teach Go, so you just have to trust that that's working. So how do we build these Go applications? We've actually got a make file, and we can just type Go build API and Go build front end. So I can go ahead, I can do that. I can say make Go build API and make Go build FE. So I'll do that. So I'm going to say make Go build API. And just as you would expect, you can do anything in your Go. I mean, all this is actually doing is just running the Go build command, and then it's going to output the API binary in the API folder. And I'm going to do the same for the front end, Go build FE. that will give us our binary files. So if I just look here, we've got a front-end binary file and an API binary file. And that's just as you would expect, the Go app itself. Now, how do we get that into OpenShift? How do we get that into OpenShift? What we need to do is create a new build in OpenShift. I've actually got these as two separate commands here. I've got OCP new build, which will actually fire off the Go build first. What we actually want to do, I'm just going to use this command just to show you it actually working. So I'm going to create a new build called FE. So I'm going to say OC new build, name FE binary. A Docker build using binary input will be created. The result image will be pushed to the image stream. A binary build was created. So we haven't actually triggered a build yet. We've just created a shell to create where to put our build. So if I just look in OpenShift, look in builds, you can see we've got a build, but last build, no build. So all we've done is created a build. We've actually started a build. There's no builds going on in there. So if I come out of there and I look at what the next commands are, it's then going to call OTP start build FE, which is this one, start build FE. And all this is doing, I'll take this command, I'll paste it in. So start build rather than actual a new build. And we're saying execute it against the FE build and do it from a file. So it's going to go in the FE folder and it's going to find that Docker file. And we're going to say follow because we want to basically follow the progress of what it's doing. It's going to start the build of this front end. Uploading directories, binary input. So it's going to load that binary file, and it will also find that Docker file. So it's pushed up the actual binary file, and now you can see that it's running the Docker steps. So it's saying from golang maintainer make directory. It's doing everything that we said in the Docker file. It's adding a label to it, FE1, saying that that's the build, and then it's pushing that image to the image repository. So that was successful. If we just go back to our builds, you can see I didn't have to refresh it. It said 6 or 7 seconds, created a few seconds ago. If I look at that build was successful, and that's basically it. We've got a build of our front end ready to deploy essentially. I can actually show you if I just look at images, we've got an image there ready to use and it's got a tag of latest. Obviously, if you were wanting to tag that, you could OC tag that latest one. If I just say OC tag latest, I'm going to say that's version 1. So I'll just tag that. If I go over to here, you can see that checksum matches the latest and 1.01 version, which is pretty awesome. So you basically see that these are the same identifier, char, checksum. Yeah, and obviously you can pull the specific version or the specific image whenever you want it. So that's just there, just as you would expect in Docker Hub, basically. So now we've got our front end image is built according to what our Docker file said. We've got an image. Now what we want to do is build the API. So what I'm going to do, I'm going to see, I'm going to actually follow the full steps on this one now and just let go into it. I'm going to say make OCP new build API. So we actually need to create the new build and then we need to start the build for it. So what I'll do, I'll run OCP new build API. Actually I won't because that's going to build it again. I'll do it in the exact same way as the other one. OC new build API. So that will create a skeleton shell. And here, builds API, there's no builds, just an empty shell. And then if I say start build, push up that subdirectory of API and follow, see what happens, run the Docker file, create the image. Oh, there we go. Do all that. So basically there we have our build already. There we go, API build complete. As you can see, there's no environment variables in the build. It's got the full log of everything it did. So I've got builds without images. If I go to the images, you can see images. I'll tag that one as well, just because I can. Oh my god. There we go. How about that? There you go. We've got version 1. So we've got our images, but I want to kick off a build basically and deploy. What we can do, we can actually run the API now. So we're going to actually essentially deploy the API, and here's where you can set any environment variables that you wish at the same time. So I'm going to say I want to create a new app. I'm going to call it an API, and that's using image stream. So that's the image stream of from our image repository. I mean, that could be a full Docker URL from Docker Hub if you want, but actually we're just using an internal reference API because we've got our own image repository. And we're saying to expose the API on port 80. So if I take that and I create the new app, it says it's created, which was pretty quick. So let's see what's happening. If we go to overview, so already we've got an API deployed on one pod, and yes, that was crazy quick. And that's how awesome it is. So what we do now is we've got the API running, and now we want to run the front end. The thing with the front end is part of the environment variable. We actually want to pass in the URL to the API, but we don't have an API URL yet. So how do we get an API URL? We expose the service. So we can do expose service API. If we just look like you can't see a URL here, you can actually say create root, but I'm using the command line. So OC expose service API. Root API exposed, and if you come here, you've got a URL already. So API my project 127.0.0.1.io. Just so happens I have done this before, so obviously I knew what the URL was going to be. So that is actually correct. If you just wanted to get that from the command line, OC get root, and you can see that the root is there on port 80. So actually the URL is exposed on port 80, but it's actually being routed on port 8080, being mapped over there. So what happens if I call that URL? Page not found. We don't have anything on that API. You have to put the correct route in to get the image. I could go and find what that is in the code because the front end calls it. The front end would call API v1 image. So if I just put that in there, we can verify that this is working as it should. There you go. If I just refresh this, every time I call this API, it's pulling back a random image from XKCD. So that's perfect. Our API is working. So now we just need to create our front end. If I go back to our front end, which is what I need to do is run the front end. So we need to create a new app. I'll pass in this environment variable. OC new app. Created. Now let's have a look at overview. We'll see that we've got front end. Rolling deployment is running. Deployed already. Look at that. Perfect. but we don't have a URL for it. So if you've not guessed already, we'll see expose service FE. We'll see get root. We've got this, so FE my project. If I go to that URL, FE my project, UK Cloud Image Gallery. And as we said, the Go Gopher is hard coded, the Red Hat logo is hard coded, and random pulls back from the API. So this is using our API that we set up. There we go. It's working perfectly. So in simple terms, that is how you deploy and build and deploy a service using OpenShift. That is a mightily simple version, but at least you've got a simple idea of how you can go about that. Now, it's all very well saying that we've got an API, but one of the biggest things at the moment is secrets. So obviously, what you want to do with secrets is to be able to put them and embed them within your application without anyone really knowing what they are. I've got a bit of an example of how you can do that in my front end. I'm actually displaying the API password. It's currently default. Obviously, you wouldn't normally expose this through your application. You would use it within your code to connect to the database with whatever connection string you want. I'm just exposing it just to prove that this works. So I'm going to literally create, I'm going to say put password in password.text. So I've got password, exciting password, right? And I'm going to use OC secret, which is a command to create a new password called API password, and I'm going to provide the password via the text file. So OC new secret, that's that password gone in there. If I just quickly come into here, you can see secrets here. So secrets, I create API password, and you can reveal secret. So there you go, you can see what it is. You can copy to clipboard, you can hide it again. So we've got a way to manage secrets already in here. Obviously, you've got all this sort of stuff, which is only accessible to obviously the admin of the project or whoever's got access. So you can still see what they are. You can actually just describe the secret as well if you want to see a bit more information. You can see that the password is 8 bytes. It doesn't really give you much information. But that doesn't currently belong to anything. Like what we want to do is put that in an environment variable so that something can access it. What I mean there is if I look at deployment, if I look at the front-end configuration, look at the front-end environment variables, you can see we've got the API URL and we've got the front-end ports, but we don't have the password in here. So how do we populate the password within a deployment configuration? We do that using our next command, which I can conveniently copy and paste. So here we go, say OC environment DC means deployment configuration. You can actually add environment variables to build configurations, but the preferred way is to deployment configuration. Prefix, you can give it API underscore, or I want to give it API underscore, and I'm going to say from the secret API password, which is already stored within OpenShift. So deployment config FE updated. So if I just come to deployment, there you go, API password is there already. And can I see what it is? No, I cannot. We'll just know, there you go, password. Deployment, yeah, it's interesting. Environment, API password. It's a password. That's not actually the password, it's just a password. So obviously, the secret, you can't see what it is. The only way you can see it is by going to the other area. I'll show you that by updating that shortly. What you will notice though, is because I updated the deployment configuration, it deployed a new front end. Because I updated the configuration, and it's really awesome, and it did a rolling update straight away, and it deployed my new version, so it's now running number 2 with the environment variable of API password set to the key and the password API password. So you can't see what it is; it's secret. No one can come in here and see what it is. And if you get to the API password, obviously you can reveal it there. But in terms of it being visible within the containers, it's all obfuscated, and you can't see what it is. So now if I refresh this, see the API password is password. So if you've got a bunch of secret passwords that you want to put in here, you don't have to worry about a complicated vault and locking the vault and unsealing the vault or whatever you may have experienced when looking at secrets somewhere else. So what about if I want to update that password? What you actually need to do is I actually need to delete that password. Let's see, delete secret API password. So I delete that password from the OpenShift area, and that has no impact on the deployments. So that's still using number 2. It's still got a password. It's just because I deleted the password, it's already got reference in memory in the containers because it's already been deployed, so it's still running. You don't need to worry about it until you go to deploy it. So now what I need to do is set a new password. So what I'm actually going to do is set that to password 2. Update this. Echo password 2. It's password. Just show password 2. There you go. And again, create this password. So I'm going to update the OpenShift to have secrets API password already exists, which is a bit odd because I deleted it earlier. Let's see, delete secret API password. Secret API password deleted. Oh! That's not good, is it? Although that does say 9 bytes now, so very interestingly, it looks like it has populated it, which is not great. Error secret already exists, but what I'm going to do is just come over here, resources, secrets. A few seconds ago, reveal secret password 2. So obviously we've got an issue here. That's not great. Secrets is a new feature to OpenShift, and obviously we need to address that. However, functionality-wise, it's updated the password. If I come here, you'll see that this is still using password. Why is it still using password? It's using password because we've not yet told it to release. When you update an environment variable, such as what I did before, I added an application deployment configuration level environment variable. If you change environment variables, it will do another deployment, but I don't need to add API password, it's already got it. I just need to tell it to release it again. So if I just release, let's see, release latest. We'll see rollout latest, rather. And I'm just going to roll out the front end because I know nothing else has changed. So deployment config rolled out. So if I come in here, you will see that I've got a deployment configuration number 3 with an environment variable and that's deployed. So if I go to overview, you'll see that it's deployed number 3. If I refresh that, it's okay to do the password too. So that is how you update secrets within OpenShift. So there you go. Thank you very much.